Pydantic AI's output validation mechanism hinges on the relationship between a model's output type, its validation context, and Pydantic field validators that consume that context via ValidationInfo. The code below demonstrates how a static validation context value, or a dynamically resolved dependency, can be injected into an agent at initialization, then surfaced inside a @field validator to transform model output before it reaches the caller. Agent runs sync drives the interaction, while represult output confirms the final adjusted value. The setup configures two agent instances. The first passes a literal integer through the validation context parameter. The second wires a deps type of deps and supplies a lambda that extracts ctx.deps.increment at validation time. Both agents share the same value model with a single @field validators that adds the resolved context to the model's x field, producing a final value x equals 15 from the model's initial 5. From data classes, import data class. From Pydantic import base model, ValidationInfo, field validator. From Pydantic AI import agent, class value base model, x int field def increment value equals value int info ValidationInfo return value plus info context or 0 agent equals agent Google GLA Gemini 3 flash preview output type equals value validation context equals 10 result agent run sync give me a value of 5 print represult output hash 5 from the model plus 10 from the validation context. Value x equals 15. At data class. Class deps. Increment, int. Agent equals agent. Google GLA, Gemini 3 flash preview. Output type equals value. Deps type equals deps. Validation context equals lambda ctx. ctx, deps increment. Result agent, run sync give me a value of 5. Deps equals deps increment equals 10. Print represult, output hash 5 from the model plus 10 from the validation context. Value x equals 15. The code shows two ways to inject validation context into a Pydantic AI agent's output validation. First, a static value of 10 is passed via validation context equals 10, which the field validator on value x reads through info context. Second, a dynamic function lambda ctx, deps, increment is used, pulling the increment from runtime deps passed to runsync. Both patterns feed the same validator that adds the context to the model value. The static context is straightforward but locked at agent definition time. The dynamic approach via deps type, deps, and a lambda gives per run control, letting you compute context from runtime state. The trade-off is added boilerplate for a more flexible pattern, and you need to ensure your deps class matches the declared deps type for type safety. Let's break it down. From data classes, import data class. From Pydantic import base model, ValidationInfo, field validator. Imports base model, ValidationInfo, and field validator from Pydantic for data validation and model definition. Class value base model. X int field def increment value equals value int info ValidationInfo return value plus info context or 0 defines a model with an integer field x and a validator that increments x by whatever value is stored in info context, defaulting to 0 if no context is provided. Agent equals agent. Google GLA, Gemini 3 flash preview. Creates an agent instance bound to the Google Gemini 3 flash preview model via the string identifier Google GLA, Gemini 3 flash preview. Result agent, run sync give me a value of 5. Print represult, output hash 5 from the model plus 10 from the validation context. value x equals 15. Calls the agent synchronously with a prompt asking for a value of 5, stores the result, then prints the wrapper of the output showing a value object with x equals 15. At data class deps, increment, int, defines a data class named deps with a single field increment of type int. Agent equals agent. Google GLA, Gemini 3 Flash Preview. Instantiates a Pydantic AI agent configured to use the Google Gemini 3 Flash Preview model. The constructor call is incomplete, with only the model identifier argument visible. Result agent, run sync give me a value of 5. Deps equals deps.increment equals 10. Print represult, output hash 5 from the model plus 10 from the validation context. Value x equals 15. Calls run sync on an agent with a prompt requesting a value of 5 and passes a dependency object where increment is 10. The resulting output is a value instance with x equals 15, combining the model's 5 with the dependency's 10. Two patterns, same validator. A static validation context equals 10 locks the offset at agent definition time. A dynamic validation context equals lambda ctx. ctx.deps.increment tied to deps type, and a deps instance gives per run control. Both feed into the same at field validatorx on value that reads info.context and adds it to the model's x field, turning a 5 into 15. The trade-off is boilerplate for flexibility, and you need your deps class to match deps type for type safety. Agent run sync drives the interaction, represult output confirms the math.
The field validator reads no context, yet adds 10 to 5 and calls it 5.